All right. We're going to begin this lesson. We're going to talk about the quadrants, okay? The quadrants, okay? This is titled is Trig Functions of Any Angle. We got 3 boxes to go over, and we're gonna talk about the quadrants. So I'm gonna move up a little bit. Okay, do yourself a favor and give yourself a pretty decent sized coordinate plane over here. Okay. Good, stuff like that, stuff like that. Good. This is of course our x-axis. This is of course our y-axis. All right. So far so good. Now. The title is the trig functions of any angle. Okay. What we're going to do is I want to give ourselves a point in quadrant number 1. So let's refresh our brain of where the quadrants, how they are numbered, okay? This is quadrant number 1. This is quadrant number 2. This is quadrant number 3. And this, of course, is quadrant number 4. There's only 4 of them. So there goes 1, 2, 3, and 4, okay? Let's give ourselves a point in quadrant number 1. And I'll just call that over here. And I'll call that point P for now. All right? If I consider point P, if I consider the distance from the origin to point P, right, I could always draw that distance. I'm going to call that a distance of R for radius if you want. All right? Then I can always draw a right triangle straight down. And I could talk about this angle in here that's called, we'll call that angle theta. So if I wanted to actually think about the coordinates of point P, well, what coordinates would they be? They would be some x value and some y value. True? So point P has just some x and some y value. Okay? So P is a point in the plane. R is the distance from the origin to that point. So R will always be positive. X is the x coordinate, y is the y coordinate, so on and so forth, and we're all good. All right? So now, how could I define what I know about trigonometry to the relationships that I see here? So for example, what would the sine of theta be in the picture drawn for us? Y. Yeah, the definition would be the value of y divided by r. It's the opposite to the hypotenuse, y over r. This relationship is going to hold for no matter which point we pick in the quadrant. Okay? So give me the cosine of theta. What would it be? The cosine of theta would be x divided by r, right? What would the tangent of theta be?
X over y over x.
Yeah, the tangent would be y divided by x. But we have to make a stipulation here. We have to make sure that x is not equal to 0. Can you think of a location in the coordinate plane where the x value is 0? Yeah. Where would it be? The y-axis, right? The y-axis. Any point on the y-axis, the x value will be 0. Agree with that? Okay. So could it be possible for some angles in which the tangent does not exist?
Yeah.
Yes. What angle would that be? Give me one angle. There's 2 of them. 90 degrees, right? Awesome. Or in radians, what would it be? Pi over 2. So think about that. If I had a point that was sitting on the y-axis, the x-coordinate would have to be 0. Therefore, I could not take the tangent because the tangent is defined as y divided by x. So let me demonstrate this for the calculator. So please take your calculators out, right? Whatever you guys have. Let's make sure right now that our calculators are in degree mode. We just realized that at 90 degrees, the x-coordinate, no matter what it is going to be 0. So if we ask the calculator for the tangent of 90 degrees, you should get what I get. The calculator gets real mad at us, right? It says domain error. Why? Because we're trying to take an angle and divide by 0 from that ratio. Can you think of another angle? 270, right? If I go all the way around to 270 degrees, then I would probably expect to see the same thing. So if I take the tangent of 270 degrees, and then I push enter, notice I'm getting the same thing.
Oh, yeah.
So there are some angles for which trig functions are not defined for tangent those happen to be multiples of 90. Either 90 or 270, straight up or straight down. I shouldn't say multiples of 90 because 180, right? That'd be something else. All right? So we have to consider that. Now, if I know the top three, then I know the relationship to the bottom three, correct? So the cotangent of theta can now be defined as what? X divided by y, and we have to state that y cannot be 0 because we're dividing by a y, right? Now, what's the reciprocal for cosine?
Secant.
Secant. Good. So the secant of theta would be defined as what? R over x, and we have to make sure that x is not the coordinate 0, right? Has the length of 0. And then the inverse of sine, or the reciprocal of sine, I should say, rather, is what's the trig function for that, you guys? Cosecant. Cosecant of theta would be defined as what? R divided by y, and y cannot equal 0 in this particular case, right? And then the relationship between x, y, and r is what it always is. R is the square root of x squared plus y squared. That's just the Pythagorean theorem. That will never change for us, and we're all good.
Where did that come?
That's a Pythagorean theorem. Okay, for the second idea, same box here, we have a new coordinate system. This is going to be very, very helpful to us, this little chart that we're going to generate. In each of the quadrants, I want you to put an S, a C, and a T. What do you think those stand for? Sine, cosine, and tangent. Very good. So let's do sine, let's do cosine, let's do tangent. Okay? Let's do sine, let's do cosine, and let's do tangent. And then finally, again, sine, cosine, and then tangent. Okay, now, think of any point that you want that's in quadrant 1. Any point you want in quadrant 1.
1, 1.
Okay? Sure, 1, 1. Any point will work, though. 1.8, 12.2, no matter what we do, right? No matter what we do, here's the point I'm trying to make. The x value will be positive. Agreed? The y value will be positive. Agreed? Okay? And r is always positive as well since it's a distance, right? So in quadrant 1. So therefore, in quadrant 1, the sine of any angle will always be positive. In quadrant 1, the cosine of any angle will also always be positive because x and y are both positive. Now, what about the tangent? Well, since the tangent is the ratio of the y to x, if I take a positive and divide it by a positive, what do I get? I get a positive. All right, good. So in quadrant number 1, it looks like sine, cosine, and tangent, all three of those are positive values. You with me so far?
Yeah.
I'm going to work my way around the quadrants now, right? Let's go to quadrant number 2. Think of any point you want in quadrant 2. All right. The x value has to be negative, and the y value has to be positive. Okay? So the sine has to be positive. That's our y value. Our x value, cosine, has to be negative. And therefore, the ratio of y values to x values of positive to negative will be what? Negative. Very good. So we're making a really nice informative chart
Wait,
here,
why
right?
is the cosine negative?
Because cosine are x values, right? Cosines are x values. See it? X values. So there we go. Okay, let's go quadrant number 3. Pick any point you want in quadrant 3. Both x and y will be negative, right? So sine will be negative, cosine will be negative, and what does that make the tangent?
Positive.
Positive, yeah. Think of any point in quadrant 3, like -5, -10, right? Okay. Now think of any point you want in quadrant 4. The x value will be positive, and the y value will be negative. So that makes the sine negative, cosine positive. What does that make tangent? Okay. So there's a really fun, easy way to remember this, and it goes something like this. A big giant A, a big giant S, a big giant T, and a big giant C. That stands for all students take calculus. All students take calculus. It's a little mnemonic device. Now, what does this mean? Here's what this means. In quadrant 1, all of them are positive. In quadrant 2, only the sine is the positive one. In quadrant 3, only the t for tangent is the positive one. And in quadrant number 4, only the c, or the cosine, is positive. So all students take calculus. always tells you the positive trig functions in the appropriate quadrant. If you remember that A is in quadrant 1, S is in quadrant 2, T in quadrant 3, and C in quadrant 4.
Why does it matter if we can just type it in our calculator? It'll give us an answer?
For this part. Why did I not write the other 3? Yeah, they're flipped, right? What's the reciprocal of a positive number? Positive, right? What's the reciprocal of a negative number? Negative. So once you know all of those, the first 3, you automatically know the second 3. Does that make sense? You guys with me on that? Okay, good. Awesome. Okay, here's a typical type of problem that we would do when learning how to take the 6 trig functions of any angle. They'll say something like this. Point P lies on the terminal side of theta, drawn in standard position. Find all 6 trig functions of theta. All right, so I would like you to do this. I'd like us to draw a picture of what we've been given. So I'm going to go the point -5, 1, 2, 3, 4, and then 5, and then go up 3, 1, 2, and then 3. So here is my point P in the coordinate plane, and it lies on the terminal side of theta, okay? So here we go. Theta is this angle here. That is the angle theta, all right? But I'm going to reference the right triangle drawn in quadrant number 2 as this as being 5 units long, and this is 3 units long. So the coordinate puts me at -5 and 3. You guys with me on that part? Sometimes I put the negative here to remind myself that I'm going in the negative direction, and then the positive 3 going in the up direction, okay? So can I get R from this? Yes, I certainly can, right? R is nothing more than the square root of -5 squared plus 3 squared, right? Which is the square root of, what, 25 plus 9? Which is the square root of 34. You guys with me on that part? Brad, 34?
Yeah.
So far so good? Okay, so now I know that R is equal to the square root of 34. All right? Good enough? Now, how do we define the things that we want? Well, the sine of theta is defined as what over what?
5 over square root.
No, it's defined as x and y, right? It's defined as 3. So that's going to be 3 divided by radical 34. But if I rationalize, what would I get?
Is it -5? Oh, yeah.
The sine is the y value, right? Look up at the very first box, right? Sine is the y value. Don't lose that. Don't lose focus on that part, right? Okay. Sine's the y value.
Wait, are we finding the sine of the blue theta?
Yeah, the blue theta. The blue theta. Okay. Then I get sine is equal to what? 3 rad 34 over 34. Agreed? Okay, good. Let's do the cosine. The cosine of that big angle is defined as the x term over the r term. What's the x term? -5 over the r term, rad 34, which of course is just -5 rad 34 over 34. You guys follow? Yeah. This is why we can take the trig function of any angle, right? Okay, let's do the tangent of my angle theta. What would it be? It's defined as y over x, right? So that would just be what? Yeah, 3 over -5 or -3/5, right? Okay, now I can find the cotangent of theta. It's just what? -5/3. I can find the secant of theta. It's just what? Negative rad 34 over 5. Yep. And then I can find the cosecant of theta. It would be what? Rad 34 over 3. And I have found all 6 of my trig functions for the given point and a given theta. Okay, here we go. I'm giving you a point, and that point lies on the terminal side of theta, and that point would be -7, -4. So let's go ahead and draw that in the coordinate plane. -7, 1, 2, 3, 4, 5, 6, 7. -4, 1, 2, 3, and 4. So if I were to draw the radius from there to that point, there's point P at -7, -4. Therefore, -7 is acting like the x value. -4 is acting like the y value, correct? So let's draw the angle that I'm looking for. Here is the angle, and I'm going to call that angle theta. Okay? I want all 6 trig functions of theta. I can just help myself visually by drawing the triangle that would give me those values in quadrant number 3. This would be -7, this would be -4, and I can consider this little angle as being the same one in quadrant 1, but I'm looking for the angle that puts me in quadrant number 3. Okay, so use the definitions that we established in box 1 and give me all 6 trig functions for the point -7, -4 lying on the terminal side of theta. Okay, awesome. Does it make sense to everybody that since we are in quadrant number 3, that sine and cosine are negative values and tangent would be a positive value?
All students.
All students take calculus. There you go. All right, you guys. Yeah.